Welcome to Motor Age's Tech Tip Series. Today we're taking a deep dive on Diagnostic Trouble Code P0101. And although you may have seen this before, this DTC can be somewhat daunting to solve on some vehicles. Stay tuned as we discuss methods for gauging the performance of mass airflow sensors and what you need to be aware of when it comes to certain Nissan vehicles. We'll also be focusing on a critical diagnostic process for the Nissan Sentra models from 2013 to 2018, specifically addressing the MRA8DE non-turbo engine. The other engine platforms affected by the P0101 issue are the QR25DE and the MR20DE. Now be aware that these platforms will have their own technical service bulletin related to DTC P0101. There is an especially important technical service bulletin related to these platforms, which may require a reprogramming event of the ECM or electronic control module in charge of engine operation. And if you happen to be a DIYer, then stay tuned as I'll provide a few tips you'll want to use when contacting a service shop to help you solve this issue. Hi, it's Scott Brown with a Motor Age Tech Tip covering the Mass Airflow Sensor Diagnostic Trouble Code DTC P0101, and it is made possible by Hitachi Astemo. Hitachi Astemo has been in the automotive business for over 90 years. During that time, they have been at the forefront of technological advancements when it comes to safety, efficiency, and the environment. They leverage their experience as a Tier 1 OE supplier for multiple vehicle manufacturers to provide consumers with the quality products that they expect using high-quality raw materials and components. Recently, Hitachi Astemo Engineering reached out and asked about doing an educational video on this topic. And when we connected for our first meeting, we discovered that this DTC is misunderstood by most, which results in misdiagnosis, wasted time, and expense. We agreed to pool resources and assemble several tips a technician can use to gain a deeper understanding about this fault, its causes, and how to successfully repair the condition. What does this code actually mean? Well, essentially, the code indicates that the ECM has witnessed a mass airflow sensor signal value outside of an expected range within certain engine operating conditions. The official description is mass airflow sensor signal circuit range performance. According to service information, either of the following conditions could be true, which would result in this DTC being set. High voltage from the sensor is sent to the ECM under light load driving conditions, or a low voltage signal from the sensor is sent to the ECM under heavy load driving conditions. So when presented with this situation, it would be wise to collect the freeze frame information so that you know which operational condition the engine was in when this fault was set. Next, we need to be aware of how this signal can be affected, which are as follows. Electrical interference. A physical inspection of the connections and wiring should be performed, along with checking the proper power and ground supply circuits, making sure you're loading them accordingly. And then checking the integrity of both the male and female electrical terminals, and make sure that they're clean and tight. Airflow disturbance. Now, airflow leaks due to a damaged boot could cause DTC P0101. And if this is something that you discover, you'll also want to make sure that the engine mounts are operating properly. Otherwise, you could have a repeat failure. Vacuum leaks can also cause this, which may warrant a leak check using your favorite method. Airflow disturbances before the sensor shouldn't be overlooked either. The air box and filter should be analyzed closely, as well as looking for anything that might disturb the normal laminar airflow. Additionally, since engines today are equipped with variable valve timing, electronic throttle, and other sophisticated engine controls, there are diagnostic algorithms running with compute cycles being carried out tens of thousands of times a minute. Some of these algorithms may have been calibrated for known conditions when the vehicle was new, but as things change, such as carbon buildup, engine wear, etc., the calibration limits may be exceeded and trigger a fault even when there isn't an actual component or sensor fault. Now, if you're addressing a vehicle with only a MIL, aka check engine light, and no reported drivability complaints, then you will absolutely need to check for service bulletins. And frankly, I think we should all be referencing service bulletins in general. On some Nissans, this is especially important because Technical Service Bulletin NTB 16-027D outlines several critical issues. The first line within the action area of this TSB states, for 2013 and 2014 models, check for an orange ring on the PCV or positive crankcase ventilation valve. If it exists, then replace it with the new one. Now let's think about this for a second. The PCV is a calibrated vacuum leak into the crankcase, and it's possible that the current flow rate on this valve is taking the total airflow measurement outside of a standard value. Now the service bulletin doesn't stop there. The next step involves cleaning of the throttle body, which in my opinion is something that should be carried out more regularly in regular service intervals. If we think about this for a minute, as carbon builds up on the throttle plate, what does this do to airflow at idle? Well, it restricts it, right? This also slows the engine down, which then requires the ECM to increase throttle opening in order to compensate. And as mentioned earlier, we have variable valve timing on engines today, and this is one of the reasons proper maintenance services need to be carried out at their proper intervals. From there, you'll need to properly perform an idle relearn procedure, which we'll cover later. Additionally, this DTC may be ultimately resolved by installing a new calibration due to what we discussed earlier. The bulletin states to read out the current calibration numbers and compare them to the list on the website. If the vehicle is subject to the update, then this is something that will need to be performed to properly repair this vehicle. Programming is something that you're likely able to complete with the tools you already have. A compliant J2534 interface and a computer meeting the manufacturer's specifications is primarily all that you'll need. The process is involved, and although we don't have time to walk through all of the details, you can refer to the links included in the description for more details. In the future, we may plan to assemble a complete end-to-end programming session so you can see and learn how it's done. Now, if you're a DIYer faced with this situation, then here are a few things you should arm yourself before contacting a service shop outside of the dealer. When you make contact with the shop, explain your situation and advise them that you believe that your vehicle may need an ECM calibration update, and ask them if they have the ability to perform all the steps outlined in the applicable technical service bulletin. Now, whenever possible, I like to grab my scan tool and record specific data parameters on my road test. And I usually do this before and after any repairs. I like to observe my before and after data so that I can ensure a proper repair and then document this on the repair order. Clients may be also interested in knowing more about what it took to properly repair their vehicle, which in my opinion adds value. The data PIDs I typically record for most drivability related complaints are as follows: engine RPM, engine coolant temperature, mass airflow in grams per second, absolute load, commanded equivalence ratio or lambda, actual equivalence ratio or lambda, short-term fuel trim, long-term fuel trim, throttle position sensor and angular percentage, and battery voltage. Now, before the road test, I like to gather specific information about the engine under test. I need to know what the exact engine size is in liters and what engine RPM the torque output of the engine is rated at. This will help us in case we suspect that there's a volumetric efficiency problem or a lean condition either caused by lack of fuel due to a fuel delivery or an under-reporting or out-of-calibration mass airflow sensor. For this engine, the MRA8DE, it has a displacement of 1,798 cc's and produces peak torque at 3,600 RPM. So what this means is that we'll need to conduct part of our road test recording data while safely carrying out a wide open throttle conditions passing through that RPM range. One can usually safely accomplish this by accelerating onto the freeway or in a similar manner. Once we do that, we'll return to the shop and place the gear selector in park, turn off all the loads, and let the engine idle for a brief period, just before stopping our recording. Okay, now let's road test the vehicle and see what we got. And as mentioned earlier, this is a CVT transmission, so it's going to be a little hard to get that engine speed. So we're going to try this from a lower speed, and then we're going to go wide open. Got some data there. All right, so we will stop our recording and we're going to zoom out a little bit. There's our wide open throttle segment there. We're going to go ahead and just zoom in on that. All right, so 3,600 RPM. You can see I'm wide open throttle there. And we go right up to about 3,600 RPM. And you see we have absolute load of 86.3. Our cylinder error is 0.46. But it looks like 87, 88, 89, 90 up here. 90% volumetric efficient. 0.474. So we'll go back, we'll do some math here and see if our calculations are correct. And again, what we're looking for is to validate that the mass air meter is actually reading correctly. The other thing to note here is that our equivalence command is 0.978, so that's just a little bit richer than stoic, right? A few percentage points. But look at what our measurement is. It's actually 0.755. That's really rich. So it's very possible that we could be over reporting airflow here. And of course, in wide open throttle, we don't have any long-term correction being applied. I don't know how much fuel trim learning or what actually takes place up in this region here, but it looks like we've got some short-term, and it's actually adding fuel. So it's a little puzzling as to why we're richer than what's being commanded. You can see we're over here, we're at lambda 1, and you see our trims are good, 30.9%. We'll zoom out a little bit here. So as we're cruising around over here, you see our absolute load 50%. Short-term and long-term fuel trim, not a whole lot changing there, and we've got really good lambda numbers. Now, with our known engine size of 1798 cc's, we'll need to find the air mass of a single cylinder. All right, now that we're back from our road test, we need to find our cylinder air, but we need to have our reference baseline. So what we need to know is that we've got 1798 cc's. We need to find the volume of one cylinder, or how much air mass fits in one cylinder. So we can basically take this 1798 and divide it by 4, and that basically gives us 0.4495. So we take 0.4495 times a constant here. And so if we look up the SAE J1979 standards for absolute load, we will find that 1.184 grams of air at standard temperature and pressure will fill a 1 liter volume, right? So what we do is we take this 0.4495 times 1.184, and that gives us 0.5322 grams for a single cylinder. So if we're road testing our car and we're able to hit that 0.5322, then we've got 100% volumetric efficiency. Now, the other issue or challenge here, of course, is how do we find that value? How do we find cylinder air when our scan tool is giving us mass airflow in grams per second? So the formula for that is fairly simple here. If you look it up in SAE J1979, it's very complex, very long and intimidating. But a quick and dirty way to find this value is that you take the mass airflow, it has to be in grams per second, okay? And you multiply that times a constant. And that constant is going to help us normalize against this. This is in grams per second, and we need to figure out, we need to divide it by RPM. So we're going to need to normalize this. And the way you do that is that you take 120, which would be 120 seconds, 2 revs of the crankshaft, all right? Because we're, again, trying to normalize against RPM per minute, and we've got seconds. So we take 120 divided by the cylinder count, and here we have 4-cylinder is a value of 30. But you can take any of these values for the engine of your choice, or you're under test, and it's going to work out just fine. All right, so what we will do is we will take what we measured in our scan tool, okay, and we go to 3,600 RPM. And why do we pick 3,600 RPM? We need to sample this at the engine's rated or peak torque rating. And when they give you a torque rating, it is at a specific RPM. On this engine, it is 3,600 RPM. We do not want to sample it up at 6,400 RPM or at a shift point or what have you. You want to go by the the rated torque, because that is where the engine is making maximum efficiency or has the maximum pumping efficiency. And that's your point of reference. And because if you do any corrections to the vehicle, any repairs, and you want to rerun this test, this volumetric efficiency test, you want to repeat it and do it and sample the data at the same RPM. Okay, so what we can do is we'll take our 0.4639. Let's get our calculator out. We'll take 0.4639 and we divide it by our constant of 0.5322, and that gives us 0.871, which is 87.1%, okay? And we would call that our base volumetric efficiency. Now, it's not an absolute perfect. There are plenty of volumetric efficiency calculators on the web. You can go out there and use them, but you do need other parameters. You need some temperature. You also need barometric pressure to find your value, but this will give you a quick and dirty number. So we can also then go up to 4,900 RPM and look at what our values are, okay? So we go 0.4817 divided by 0.5322, and we have 90.5. Okay. So why would we have a higher number? Well, this engine does have variable cam timing, so it is very possible that it could have a wider volumetric efficiency range. It is also very possible that this engine's mass airflow meter is actually over-reporting. And the reason I say that is if you look at our data from our road test, you can see that our lambda number is much richer than what's being commanded. And that is very possible of being indicative of higher airflow being seen by the PCM. It's trying to add the corresponding amount of fuel, and it's actually overfueling it because that number is high. Now, we didn't go out and test for this particular thing on this video, but that gives you some perspective. But you can take these numbers and establish them as a baseline and say that you're going to do a repair. You would go back out and repeat your test at the same speeds and record your values. All right? The other thing that I noticed and I find this useful for is also finding the cylinder error at idle, okay? And you saw that my scan tool actually calculates that value in real time, and if you carry that out over 4 digits, you can get a good idea of what is normal for your idle airflow calculation. Compare that to the throttle opening, and that could give you some indication of what maybe that the throttle body needs some type of service work as well. Now, if we've issued corrections to the vehicle, including cleaning of the throttle body, we'll need to perform our next steps, which is performing the idle airflow volume relearn as per the service bulletin or service manual. As per the service bulletin, we need to ensure that the engine is at proper operating temperatures. Using a capable scan tool, we'll enter the idle learn procedure and follow the prompts. This is where we would go to do the idle air volume relearn. The tool here provides us with a lot of information on what we need to do. This is where you need to run the car till we get that coolant temperature between 70 to 100 C. Recommended to stay below 80 C, so that's interesting. Load off. Okay. Okay. And then this is where we would start. Okay. And see, it says waiting for your operation. Now, we just covered quite a bit, and I hope you learned something along the way. Remember, accurate diagnosis can save time and helps in delivering competent service. Well, that's a wrap for the Hitachi Astemo Tech Tip on diagnosing DTC P0101 on some Nissan vehicles. Stay tuned to Motor Age for more expert advice and tips. And if you have any questions or comments, please leave them below, and thanks for watching.